This is the ocean sunfish. 2 tons of flesh, taller than a grizzly bear, the heaviest bony fish on Earth. And if you ask the internet, this might be the worst designed animal evolution has ever made. It's slow. It barely even looks like a fish. And it doesn't actually have a real tail. Some scientists once joked it looks like a normal fish that got cut in half and decided to keep living anyway. People call it the dumbest animal alive. A floating head. A biological mistake. And honestly, at first glance, it kind of does look like evolution just gave up halfway through building it. But here's the weird part. Despite looking completely broken, this thing has survived for millions of years in every major ocean on Earth. So maybe the real question isn't why the ocean sunfish looks wrong. Maybe the real question is, what if this is actually one of evolution's smartest designs? Before we get into it, if you're into prehistoric monsters and evolutionary weirdness, make sure you're subscribed. We do this every week, and you do not want to miss what's coming next. Now, here's where the sunfish starts to look unfinished. At first glance, it honestly looks like a normal fish that got cut in half, and that's not far from the truth. Through evolution, the sunfish completely lost its true tail fin. The back end of its body just stops. Instead of scales, its skin is wrapped in a thick, rubbery layer of tissue, sometimes up to 15 centimeters thick, rough and textured almost like sandpaper. So right away, it breaks 2 of the basic rules of being a fish: no real tail and no proper scales. Which raises an obvious question. If it doesn't have a tail, how does something this massive even swim? Most fish move by bending their bodies side to side, pushing water backward with powerful muscles along the spine. But the sunfish can't do that. Its spine is extremely short and rigid, and it simply doesn't have the muscles needed for that kind of motion. So, evolution came up with a completely different solution. Instead of swimming like a fish, it flies underwater. The sunfish moves by flapping its enormous dorsal and anal fins together, perfectly synchronized, like a pair of vertical wings. Up, down, up, down. That motion generates lift-based thrust, almost exactly the way wings work in air. And weirdly enough, scientists have found that its movement patterns look strikingly similar to animals like penguins, sea turtles, and manta rays, all creatures that fly through water. It's a perfect example of convergent evolution, completely different animals arriving at the same solution to the same problem. But there's one huge difference. Penguins, turtles, and rays all use horizontally oriented wings. The sunfish is the only known aquatic vertebrate on Earth doing this with vertical wings. The result isn't fast. On average, a sunfish cruises at around 3 kilometers per hour, slower than a casual bicycle ride. But speed was never the point. Hydrodynamic studies show this motion is incredibly energy efficient. It sacrifices bursts of speed in exchange for endurance, allowing a giant animal to travel long distances while burning very little energy. And that trade-off matters a lot, because the entire lifestyle of the sunfish is built around one harsh reality. It survives on the ocean's leftovers. it can't chase fast prey. Instead, it specializes in animals most predators ignore: jellyfish, comb jellies, and gelatinous plankton. Food that's mostly water and almost empty of calories, which means surviving isn't about being fast. It's about being efficient enough to live on almost nothing. So, the question is, if your food barely contains energy, how do you grow into a 2-ton giant? Because the ocean sunfish doesn't hunt fast fish. It doesn't chase squid. It doesn't compete with predators built for speed or power. Instead, it eats what nobody else wants: jellyfish, salps, siphonophores, drifting blobs of gelatinous plankton floating through the open ocean. And here's the problem: these creatures are made of about 95% water. Nutritionally speaking, eating jellyfish is almost like drinking seawater and hoping to feel full afterward. There's barely any protein, barely any calories, almost no real energy. So the sunfish solves the problem the only way it can. It eats constantly. Not just a little more than other animals, massively more. Every day, a single sunfish may consume hundreds of kilograms of prey, thousands upon thousands of jellyfish, just to meet its basic metabolic needs. It doesn't chase its food. It simply moves through it, eating almost non-stop. Its mouth is surprisingly tiny, and its teeth are fused together into a hard, beak-like structure inherited from its pufferfish relatives. In fact, its jaws are fused so tightly that it can't fully close its mouth at all. So, biting and chewing are off the table. Instead, the sunfish feeds using suction. It expands its throat cavity, creating a low-pressure zone that pulls prey straight inside, jellyfish, tentacles, and all. But the real work doesn't happen in the mouth. It happens deeper. Hidden inside its throat are specialized pharyngeal teeth mounted along the gill arches, sharp, backward-curving structures that act like a biological shredder. Scientists have compared it to a slow but incredibly efficient wood chipper. The jellyfish are ground into pulp before they ever reach the stomach, breaking down soft tissue so completely that the fish can absorb every last trace of nutrition from food that barely contains any in the first place. Because when your entire survival depends on eating something that's mostly water, waste isn't an option. But even eating non-stop isn't enough. Jellyfish don't stay near the surface all day. They migrate, rising toward sunlight at night and sinking back into darkness during the day. And if the sunfish wants to keep eating, it has to follow them, which means diving into parts of the ocean where almost no large animals are built to survive. To find enough food, the sunfish has to go somewhere most giant animals avoid: straight down. Every single day, ocean sunfish make massive vertical journeys through the water column, diving hundreds of meters, sometimes more than 1,000 meters deep, into what scientists call the midnight zone. Down there, sunlight disappears. The temperature drops to around 4 degrees Celsius, and the pressure is crushing. So why go there at all? Because that's where the food goes. Every day, tiny organisms like zooplankton and siphonophores migrate up and down through the ocean in one of the largest movements on Earth, a daily vertical migration. And the sunfish simply follows the buffet. But this creates a serious problem. Most bony fish use a swim bladder, a gas-filled organ that helps them control buoyancy. The deeper they go, the more that gas compresses under pressure. Rapid depth changes can become dangerous and extremely energy expensive. But the sunfish doesn't have that problem, because adult sunfish don't have a swim bladder at all. Instead, evolution gave them something much stranger. Beneath their skin sits a thick, rubbery layer called the hypodermis, sometimes up to 15 centimeters thick. It's made from dense collagen and elastin, packed with water, almost like living gelatin. And water doesn't compress. This layer is slightly lighter than seawater, perfectly balancing the weight of their muscles and bones. So, instead of constantly fighting pressure changes, the sunfish moves freely between depths with almost no extra effort. It isn't just floating. It's operating like a biological submarine. And this strange design explains something people constantly misunderstand about the animal. Its brain is tiny. A sunfish can weigh over 2 tons, yet its brain may weigh less than 5 grams. That sounds ridiculous until you remember what it eats. Brains are incredibly expensive organs. They burn enormous amounts of energy just to function. And when your entire diet consists of jellyfish that are mostly water and barely contain calories, energy becomes everything. So the sunfish didn't evolve a large, complex nervous system. It evolved efficiency. A minimalist brain reduces energy loss, allowing more resources to go towards survival, growth, and constant movement through the ocean. In other words, nothing about this animal is accidental. It didn't evolve to be smart in the way we define intelligence. It evolved to waste absolutely nothing. After these deep, freezing dives, the sunfish comes back to the surface and does something that looks completely ridiculous. It just lies there, flat, sometimes sideways, apparently doing absolutely nothing. For years, people thought these fish were sick or dying, but they're not. They're reheating. Because they're cold-blooded, their body temperature drops during deep dives, sometimes from about 20 degrees Celsius down to nearly 12. By lying at the surface, they absorb heat from the sun and warm themselves up before diving again. But that's only half the reason. The other reason is hygiene. A single sunfish can host dozens of parasite species, so many that even the parasites sometimes have parasites living on them. So when it floats at the surface, it's basically sending out an invitation. Seabirds like gulls and albatrosses land on it and pick parasites off its skin, while smaller fish clean the underside below the water. It becomes a floating cleaning station. Even though they look defenseless, adult sunfish are rarely worth attacking. Predators like orcas or great white sharks often give up because the effort just isn't worth the reward. And the reason is simple. Its skin is thick, leathery, and incredibly hard to bite through. And underneath that armor, there's barely any reward. Nutritionally, a sunfish offers so little energy that scientists have jokingly described them as something like watery, cartilage-filled jelly donuts packed with parasites. In other words, a lot of work for very little food. So once a sunfish reaches adulthood, most predators decide it's simply not worth the energy. But that protection doesn't start at birth. In fact, early life is brutally dangerous. A female sunfish releases an almost unimaginable number of eggs. sometimes up to 1 billion in a single spawning season, more than any other vertebrate on Earth. But there's no nest, no protection, no parental care at all. The eggs and sperm are released directly into the open ocean and almost immediately become food for everything else living there. About 99.99% will never survive. But evolution isn't relying on protection. It's relying on probability. Release hundreds of millions of offspring, and mathematically, a few are almost guaranteed to make it. The survivors hatch into something that barely resembles an adult sunfish. The larvae are microscopic, smaller than a grain of sand, and covered in a transparent, spiky shell inherited from their pufferfish ancestors, giving them a tiny, armored defense against predators. And then comes one of the most extreme growth spurts in the entire animal kingdom. To reach adult size, a sunfish must increase its body mass by roughly 60 million times. That's like a human baby growing into something the size of a skyscraper. In one documented case at the Monterey Bay Aquarium, a young sunfish gained nearly 1 kilogram of weight every single day for 15 straight months. Growing fast isn't just impressive, it's survival. Because once a sunfish becomes enormous, wrapped in thick elastic skin and sheer bulk, very few predators can bite through it, swallow it, or even bother trying. Its size becomes its shield, and suddenly, the animal that looked defenseless becomes almost untouchable. For millions of years, the ocean sunfish perfected a survival strategy that worked almost flawlessly. Grow fast, produce enormous numbers of offspring, become too big and too tough to bother attacking. It survived predators. It survived changing oceans. It survived by becoming perfectly adapted to a very specific ecological niche. And then something appeared that it never evolved to understand. Humans. Today, one of the greatest threats to adult sunfish isn't nature at all. It's Homo sapiens. The modern ocean is changing faster than this slow-moving animal can possibly adapt to, introducing dangers that simply didn't exist during its evolutionary history. Take boat traffic. Because sunfish are cold-blooded, they often float flat at the surface to warm themselves after deep dives. The same behavior that also invites seabirds to clean parasites from their skin. From above, they look like harmless, drifting shapes. But to a speeding boat, they're almost invisible. Ship propellers and rudders can strike them easily, turning a simple moment of thermoregulation into a fatal encounter. And below the surface, the danger continues. Sunfish drift slowly through the water column, which makes them frequent victims of fishing gear. Drift gill nets, designed for entirely different species, can snag their bodies, tear their thick skin, strip away their protective mucus coating, and even trap air in their gills. An animal built for endurance suddenly can't breathe properly. But the most tragic threat might also be the simplest: plastic bags. To a sunfish, a floating plastic bag looks almost identical to a jellyfish, the exact prey it evolved to hunt. So it does what it has always done. It opens its mouth, creates suction, and swallows. But plastic can't be digested. The bag can choke the fish or block its stomach completely, leaving it unable to process real food. Slowly, the animal starves, not because food is gone, but because its body believes it has already eaten. And that's the cruel irony. The sunfish is not poorly designed. It's a highly specialized biological machine, perfectly tuned for the natural ocean. But evolution prepared it for predators, pressure, and scarcity, not for propellers, not for fishing nets, and definitely not for plastic. So, after everything we've seen, the ocean sunfish still looks strange. A fish without a tail. A giant with a tiny brain. A slow swimmer surviving on food that barely counts as food. At first glance, it feels like evolution made a mistake. But evolution doesn't care about appearance. It cares about survival. Every weird feature, the simplified body, the thick skin, the endless appetite, the massive reproduction, isn't a flaw. It's a solution. The sunfish didn't evolve to be fast or powerful. It evolved to waste nothing, and to survive where almost nothing else can. Sometimes in evolution, the animals that look the most wrong are actually perfectly designed. So next time you see a sunfish floating at the surface, ask yourself, is this animal broken or brilliantly adapted? Let me know what you think in the comments, and tell me which strange ocean creature we should explore next. If you liked this video, support us by liking and subscribing for more similar journeys.